Yes, so today we're going to have two short examples where we're going to see how you can implement a model which you can provide a user interface for. So the first one is querying the SMHI websites or services for weather data and how you implement that in Python. So the idea is that there is a repository here, Open Data, and there is an API which you can call with and get JSON file, and you know JSON file. So and from that JSON file, we can then extract information. So to kind of start off, I decided to implement SMHI class, which implements all the details. And the idea is that it will query the data at a certain longitude and latitude. So to create an object, you need to kind of specify the longitude and the latitude here. If you don't do that, the object will automatically assign a default longitude and latitude. So what do I store in my object here now? So as you can see here, this is kind of a sketch of an object, so I haven't done any properties or anything, just kind of simple first start of an object or a class. So of course we need to kind of get the URL, and we can actually look at this URL here, and you can see here this is the home page of Open Data at SMHI, and you can see here there are what you can access here. So that URL I store here in the URL attribute of the class. And then there is an API, which looks like this. The curly braces here are additional parameters you have to specify in the API. So the first ones here are the category and the version. So you can see here I added those as attributes to my model as well. It could be that I want to change that, and then you can update automatically. There is two longitude and latitude parameters in the API, and I store them here as well. And then I have implemented the actual querying of the forecast in a separate method of the object. So when you instantiate the object, nothing happens directly until this last point here. So I put that in a separate subroutine, so that you can, after you have created the object, and you can repeat this by calling it again. So the first thing we have to do in this method is to assemble the API call. So what we do then is we have the template here, which we have added in our attributes, and then we use the format statement here to replace those curly brackets here. You could of course also use the format string, the F strings. Then you can put variable names directly into the template here as well. But this is the kind of classic way of doing it. So format, so self-category goes into this first curly bracket, version into the second one, longitude and latitude in the last ones here. So now we have the API string. And if you want to access,
Silly question.
Yeah.
Indentation sensitive language, and you have marked a lot of indentation here.
Yep.
What is not the problem?
There's no problem here.
Yeah. So
The thing is
it's
that
not obvious to me that it's not a problem.
no, so you can actually have, as long as the outer layer here is okay. If you have a line that continues, you can continue here and have as many as you want. So the important indentation is the first part here.
Yeah. But what is the official line break then? When the proper line ends with the
There.
somehow. Okay.
So you can continue here, and it belongs to this call here.
Right.
It's just that to make it more readable, to make it shorter.
Yeah.
You could have also one thing you also see sometimes is that you have. Let's see if we can do this. So it did the same thing.
Yeah, right.
So the formatting is so recommended in Python.
I mean, it makes sense.
Yeah.
It was just not obvious to me that it's not a problem.
Yeah. So that's So I usually, that's a good idea. There is a tool in Visual Studio Code called AutoPep8. And it's a command line to you. If you don't use Visual Studio Code, you can use it in the command line. That will format your code according to the latest what the guides and recommendations with Python. So it's a good way of quickly formatting your code and making it readable. So what we need to do now is we have to go out to the web and access this API. And in Python, there is a module called requests. So you can see here I have imported JSON because we need to process JSON. And we have added request here to be able to access data on the web. And request get is the kind of actual call. So here you provide your URL and your API. And this will return the output from the request from the web page here. And then we need to process it here. So the first thing I will do is I'll just print it out here so that you can see how it looks when we get it back. And I think I have a test here as well, yes. So if we run it here now, okay, a response. So what you get back is a response object. So that's why this is the object here. But if I run it here again, and there is an attribute called text. So you can see here that we got back from the API a JSON output here, a lot of it. And we need to parse that. So that is the actual response from the API at SMHI, and we need to process that. So let's see here if we can... So next we need to kind of get that into format that we can read or process. So then we have the JSON loads, which you used before with the load. Load S means load the JSON or process the JSON as a string. And this SMHI info.text, that's a string. And back we will get a Python data type, a dictionary, which we can query. And then the next step is to have a parameters value here, which is a method that you give it a parameter name, and then you get the date, times, and the values back from it. And we can look at how this is. It was here I create 2 empty lists, and then I loop over item in forecast time series. And then I get the parameters here, which is the item. There's a dictionary here with parameters. And then for parameters, a parameter, and then I check if parameter name is equal to name. I append them to the list here. So because of this is a dictionary, dictionaries and a list, you have to loop over it and extract the data. So if we continue here, we just stop here. We can print the date times here and the values. So you can see here what I get back here is the dates where the data was collected, and I get the values here in a separate list. And now we can plot this using Matplotlib. The only problem here we have is that we need to handle the dates in a special way here. So there is a special method called plot date, which you can use to plot date here. I don't go through too much about the details here, but there are some extra things you have to do here. But if you run this, we go out to the so you can see here that we have date formats here on the lower part here, and we have the plot of temperatures here in the rest of the diagram. So what we have done now, we have created an object that can query the data from SMHI. You can get the data back, and then you can see we can plot it as well. So in the next part here, I will create a small weather application so that I can put in a longitude and latitude, and I can query and create a diagram on different locations. So the first thing we will do is to generate the user interface. And I have, like a cook, I have already pre-prepared this. So the first thing we start the designer application. Could be Qt Creator as well. And we then open. I have created a weather app UI here. So here I have created the parameter here, a text box or combo box that you can drop down to select the parameter you want to plot. I have a text box for the longitude and latitude. And what I usually do when I code a user interface is that I'm name my controls in a way that I can find in a logical way. So the parameter here is param combo because it's a combo box. The longitude is long edit here, and I have lat edit, and then I have a button called refresh button. So I add kind of what the type of control it is at the end. And the thing is that the user interface looks a bit strange now, because what I want to do in my application is to insert matplotlib into the application here. So there will be an additional control here that will be the plot. But the basic user interface is assigned here, and I leave room for the matplotlib here in the user interface. Like that. So I save this as a UI file, and then I open my weather app Python application here. The magic part here is that matplotlib provides a user interface control for Qt, which you can insert. Somehow they made this extremely complicated to do, or how to get the widgets that you can insert here. So the magic is this here. Matplotlib backend Qt5. So Matplotlib can provide widgets for different user interface toolkits, not only Qt, but we need the Qt ones because we are going to insert it in the Qt application. So backend Qt5 aggregate somehow, I don't know why it's named like that. And we import this figure Qt ag, and we rename it here so it's a bit more logical. So this is what you can do in Python. You can import things from modules, and you can import a certain class, and you can also rename them in the same import statement. So we need a figure canvas that is the actual plot, and we need a toolbar for controlling the plot as well. And then we import the normal matplotlib stuff here, and we implement our weather window here. And the application is inherited from a Q main window, and we can go back here to Qt Designer and see here, if we go in the hierarchy here, you can see here the main class here is a Q main window. So in our source code, we need to make sure that we inherit from Q main window as well, and it's there. And then I do a trick here because the UI files I usually place them in the same directory as the main source code file. But you need to find that, if you place the application somewhere else, you need to find that UI file. So what you can do then is to, you can use the sysargv here, because the first 0 argument of the sysargv variable actually contains the executable, the name, so the full source code of the executable. So what I do then is I extract that, and then I get I split the path here and extract the directory path part of that. So now I have the application directory. So now I know where to load a UI file from. So then I do load UI, and then I do join here, application directory with weather app UI. And I provide it here. So the load UI function will load a UI file and create the objects at the location we specify. So self here is our own object. So we want our user interface objects to be created directly in our object. You can specify that you want to have all my user interface things put in a variable called UI. But usually it's much easier to have it. I think it's easier to have it directly in the user interface class.
Sorry, I lost it. UIC, what was that again?
It's a user interface compiler. So that is a module that comes from PyQt5 that can read UI files and create objects from that. So it reads this XML file that is generated by the user interface designer, creates the objects, and so this is part of QtPy.
There, sorry,
Yeah.
Over.
There is another way of doing this as well. There is a command line tool called PyUIC5 or 6, which can take a UI file and generate a Python class, which you can mix into your class. The benefits of that is that you get a single source code file. You don't have the UI files. You can have not only Python files. But I think UI files work better. There are some certain cases where it's more useful to have the PyUIC compiler separately, especially if you want to have more. You don't want to rely on UI files being part of your application. You want a single standalone Python application. So now I've created my user interface things in my my class. Next, I need to create my SMHI object because that's kind of a core functionality. So I instantiate an SMHI object. I define a variable here that sets the current parameter that we want to use. And then we create a figure widget. So first we create the normal Matplotlib figure, and we get the object back here from this one. Then we create the figure canvas, which we give it the figure object. And then we create the figure toolbar, and also give it which canvas it controls, attach it to our main window here. And then we add the main widget here, that is the main window. We add the widget self canvas, and we make sure that it expands as much as possible, set the size quality, and then we add a toolbar as well. So we have, in addition, we have our buttons here, and then we add first the canvas and then the toolbar. Then we also say that we connect the current text changed signal from our combo box to on text changed. We assign the refresh button clicked method to on refresh. We request the forecasts here, and we go down to here. We call our SMHI object here to get our values. We have a update controls method here that sets the controls from our model. And then we have an update model here to update the values in our model as well. And then we have plot here to actually plot our data here. Refresh, that calls our update model again, request a new forecast, and calls plot again. And refresh just calls that one, the button method here. And if you change the text here in the combo box, it will call refresh again. And then we start it like this. We create a window, we show the window, and then we execute the application loop. If we run this now, okay, it ended up here. So now we have, you can see here that we have an application here that uses Matplotlib as a widget here. We have our own user interface on top. We can go to temperature here. And you can see we can plot the things here. We can change the longitude. I don't know if it matters anyway. But anyway, that's the kind of idea that you have. We can use our model here, and then we have integrated Matplotlib into your application. So that is one way to create diagrams in your application, that you actually insert Matplotlib into your application and create a user interface around that. And this is the actual toolbar from Matplotlib here. So this is something we just added to our own user interface, and that controls the we can zoom in here to a certain point here. And there is also a control here to change the parameters of the diagram. So this shows you how you can separate the user interface from the model. So SMHI here, this class here is completely independent from the user interface. So all the logic of an application is in our SMHI class. And then we have the user interface in a separate class here, or no, this one, this one here. That's completely here. So the only connection we have to the model is this line statement here. We create a model object, which we then use to populate the user interface, to update the user interface, and we take the data from the controls and give it to the model, and vice versa. So this is a very simple application. We can do a bit more. So my background is in structural mechanics. So let's see if we can do a beam application here. So let's close this one here. So this is a bit more larger application, but the idea is the same here. So you can see here I have a beam model that implements my computation model. I have several modules here that implements different parts of a user interface. I have a main application here. That is where the app loop is, where the main window is. I have here additional windows here for editing the segments, the supports, and I also have a beam view here to visualize the beam in the window as well. It will also use Matplotlib to draw. However, I have added a special view class here to be able to draw things in Matplotlib. So feel free to take that and use it in your own applications. It's not very complicated, but you can do some things like draw a line, a polygon, rectangle, circle, triangle in this canvas. And I've implemented the beam view here to be able to draw my beams. So I have a view of my model. But we start with the model. So let's see here. So you can see here I have a class here. There is a beam model, and my beam model has a beam in structural mechanics is I think we can't see it here, but this is the girders going here, and they are supported on multiple supports, and the supports can be either fixed in X and Y direction, but it can also be fixed in only one direction. So it's fixed in the Y direction and it can move like rollers. So in my model here, I have 3 support types. So I have fixed in Y direction, fixed in XY direction, and fixed in XY and rotation. You can see these are not variables in a normal sense. These are, I would say, constants that are defined in the class itself. So they will be the same. Every object will have the same values of these constants here.
But they are only constants because there's no way of changing them in the class, or
no, exactly. So I put them. Normally, you put your attributes in the constructor to attach it to the actual object. Here, these variables are attached to the class variable itself. So that's one way of putting constants in classes that you want. Instead of having numbers to define types, you can have like this. And so I decided to, in this case, to have, because the user of this application will be able to create new beams and save them and open them, I decided to put all logic of this into this class. So in this case, I have a method called new, which will create a new beam model. So the first thing I do in the constructor here is I actually call new. And in new, I set the attributes here. So I decided to put the segments of the beams here in a list. So the first segment is 2 meters, the second one is 3 meters. Segments here is the resolution of the calculation. So in the first segment, I have 10 calculation points, In the second one, 20 calculation points. I have loads here for distributed loads over the first beam, distributed load over the second beam. And then the supports here. In this case, I have 2 segments. I have 3 supports. So I just add them here. So I have the first node is fixed in X and Y direction. The second support is fixed in Y direction only. And the final one is fixed completely at the end. So X and Y are directions. And then I have some other attributes here which I will use later on. And when I don't have defined anything that it's not used any or created yet, you can use none. You can also query if a variable is none. And that is a way of kind of making sure that you have a variable reference, but you haven't defined it yet. So you can use it as if is none, then do something otherwise. So these have not been defined here, so I have a variable for the X displacement, Y displacements, the section forces, and so on, but I define them as none here. Then I need a method for solving the equation system. So I have a method called solve. We do a lot of mechanical calculations here. We have properties for each segment. We find some other things here as well, but here is I define the global stiffness matrix. I calculate the number of degrees of freedom in total depending on the number of sections and supports. The load vector, the topology, and then I do some calculations here. But I loop through the length, segments, and loads, and I create elements, and then I assemble them into the global stiffness matrix, solve the system. This is kind of mechanics. I solve the equation system. I store the results here in result variables. So NVM, that is the section forces, and X is the displacement vector. Now, so that is the X positions here, and then we store the displacements here as well. And then I have a save method for the object here, save as JSON. And here you can see here I create a dictionary here for the beams, and then I store each of the variables here as with keys, and then the value for that in that key. And then I just dump the JSON file to disk. Same thing, I go the other way around. I load the beam model from disk, open. I load it from a JSON file, and then assign the attributes from the JSON file that I loaded in the dictionary that was created from the JSON file. And this is how you can use this model. You create the beam object, you set the lengths, you set the segments, you set the support, you set the load, and call solve. I don't know what happens if I run this. Nothing happens. So we can use Matplotlib here to plot the output. Okay, I forget to define Matplotlib. So here I have the displacements and the moment, and yeah, just plotted in Matplotlib directly here. So I have an object that can solve a set of segmented beams connected together, continuous beam. So now I have my model, so I need to create an application. And in this case here, we can go into the designer here and open the user interface files. Close this one here. The main user interface looks like this. I have a toolbar. I have a menu here I have one menu that can open you can edit the beam length and the beam properties. One menu for editing the supports. I have new model, open, save as. And if you're working with Qt Designer or Qt Creator here, you have in the lower part here the action editor. So when you create a menu, there is automatically an action is created here. And you name them, I usually name them here, that's just like a button here, but I put an action here at the end. Open, save, save as, exit, new action here, segment action, BC action. And to add, so when you create a toolbar from scratch, it's empty, but you can drag and drop things on the toolbar. I think you should be able to do that at least. It's only, let's see if we can exit action here. Yeah. So then you drag the action to the toolbar, and it's added to the toolbar automatically. So let's remove the exit here. I apparently can't remove that. Let's do that now. Remove exit action. Okay. So that's toolbar. I also have another user interface for the segment here. Looks something like this. So I have a list box here with all the segments of the beam, and then you can click here and select either geometry, load, and material. So you can edit that. I also have beam supports that lists the support of the beam, and then you can specify either X, Y, XYR, and Y here. And these struts here, I talked about them before, those are kind of to make sure that the user interface is scalable, and it pushes up the different controls to be on the top and so on, and this button to the right, for example. So if I change it, you can see here that the button will be pressed out. If I change the size here, the radio buttons will stay on the bottom here. So how that is implemented in my beam application. So here you can see here I have implemented my beam model as BM. I have a beam view as BV, beam segments as BS, and supports as BSP. This beam rest here, that is a special Python file that you can create with a user interface compiler that contains the icons for the toolbars. So it's compiled into a Python file here. You can see here, these are the images for the toolbar that are stored in a normal Python file. So let's go back here. I load my user interface file here. In this case, I wasn't so thorough to kind of actually use the sys arguments to do this, but this application requires that you start the application in the same directory as the UI files. I create an attribute for the file name that is empty. I create two variables here for the windows that we will open the dialogues. I have a method called new model to initialize a new model. I create the canvas for be able to draw my beam. And I attach a toolbar here as well. I create my beam view, which I associate with the figure from Matplotlib, give it the beam model here. So here I give the beam view an instance of the beam model. So the beam view will look at the beam model and use that to draw the actual beam. But the beam model itself doesn't know anything about drawing, so it's just kind of an information carrier. We can pass that around the user interface. And here we have our different embed methods here. So you can see here an exit action, triggered, connect, and then we connect that to my method in my class here. So if I create a new model here, I do approximately what we did before. I create some default values. I create a new beam model, and I solve it directly here. This is not a significantly complex computation, so I can do it almost immediately. And you can also see here, when I create a new model here, we click new, we do the new model, and we update the beam view to draw the new model here. Exit, we just do close. Open, we get the file name. And then you can see we do beam model new, open from JSON, give it the file name, solve it again, draw the model. So I tried here to avoid having a discrete computational step. So every time you open something, there is a new calculation being done. If I change any parameters, the calculation is updated immediately. Save as, basically the same. If you click on segments, it will open the beam segments window. So you can see here I create a new Qt window here. I give it the beam model again. So I pass along my beam model over to the user interface that wants to edit it. And also I give it a beam view here so that the user interface can update the beam drawing as well. And I do the same for the support window here. And you can see here, we start the application just like I showed you before. Enter the application loop like this. Running this, hopefully it will work today. You can see here that there's something wrong here. It shouldn't be that. It should be this one is the correct one here. So you can see I draw my beam here. This is the beam view. The entire area here is the beam view. And it draws the beam here, kind of representative of the loading here. So you can see how this is distributed load, and this is the half the load of the previous one. You can also see here that it's I have a X, Y, and rotation is locked here, so this beam is fixed at this end. You can see here that the displacement here goes to 0 here. And here you see it can rotate, so the displacement goes directly down here. It goes up to 0 here, not perfectly in line, and then to 0 here again. And when I go in here and, for example, open my user interface for the beams, I can change, for example, the first one here to 4 meters. Update. And you can see it does the calculation again. I can change the loading here to minus 2000. And you can see here it updates the model here again. And we can do that with the middle one here as well. I'll give it some 4 meters. And you can see I can change the model here. But also notice here that the user interface is completely disconnected from the model. The model doesn't know anything about the user interface. The model does all the computations. It provides the information for the view of the model. So we could take the beam model module, put it in another application, and run it as a web application. We just re-implement the user interface parts in a different way. So that's if you want to learn, take something away from user interface, is always try to disconnect the user interface implementation from the actual computational model, and so that you don't kind of mix them. It's also easier when you want to do some parallelization or make it more scalable, that you can focus on the computational model and not having a user interface that is deeply interconnected into the computational model. So and you can also here, if you go to support here, I can fix it on the other side here as well. So now it's fixed on this side as well. And you can see here that X and Y is 0, and the rotation is fixed here, so it starts kind of from horizontal plane and goes down here on the same side here. We can of course X, Y here, and we can go to the last one here and put it X, Y here. So now it's fixed on both sides here. Usually you have it only like this to be able to rotate here. So that was what I wanted to show you today, how to implement a bit larger